Hey, Algebra 2, welcome back, guys. Here we go into section 4 today of chapter 6. We are talking all about factoring polynomials. Now listen, I know you've done factoring before, so some of that is similar. And one key piece that will be different is when we get into, as you see on the screen, kind of down at the bottom there where it says sum and difference of two cubes. That's going to be a little new. But we start with a little review actually of section 3, when we were doing long division and synthetic division. All right, I'm sure you really enjoyed that. I'm sure you can pick up on the heavy sarcasm there. But we're going to do an example problem of synthetic division just to make sure you guys are still comfortable and good with that, because you will be doing some of that in tonight's homework. And I need to make sure that you are comfortable with it because we're going to keep working with that throughout the rest of the chapter. All right, so let's just jump into it here. Factoring polynomials, as you can see, remember long division and synthetic division. For the example problem that we're doing today, it's going to be focused on synthetic division, nice and easy. And you remember long division goes with coefficients of 2 or more, synthetic division with a coefficient of 1. Okay, so again, kind of follow the color coordinated notes there. It's a little helpful. Now, next part, to determine if the binomial is a factor, you're going to need to use division. And again, determine which is the best division, whether it's long division or synthetic division. And the key part you're looking for is it has to have a remainder of 0. So when you get to the end of the problem, you basically don't want any remainder, okay? So for synthetic division, you want your last step to give you an answer of 0. If you're doing long division, same thing, everything cancels out. Okay, so we're going to do an example today where we will be using synthetic division, and we're going to see if we get a remainder of 0. Okay, now the next problem that we're going to take a look at is going to be a factor by grouping, and that's when you're going to have more than 3 terms. All right, if you have 2 terms or 3 terms, you can just use regular factoring. But factor by grouping is when you have more than 3 terms, and you're basically going to be looking at something with 4 terms. You're really not dealing with anything that has, like 5 or 6. So if you really want the specific thing, when I say more than 3, we're basically looking at 4 terms. Okay, and then the last thing is this guy right here, sum and difference of 2 cubes. So take a look at that picture right there. You got to copy that down into your notes. And we're going to be doing problems like this on examples 3 and example 4. Okay, so there you go. Take the time, copy this down. Let's move in to our example problems. Okay, so example problem number 1 here. You're given the binomial x plus 2, and you got to determine if that is a factor. In other words, will x plus 2 perfectly evenly go into the polynomial 4x squared minus 2x plus 5? So we're using division, specifically synthetic division, all right, because we have a coefficient of 1 with the binomial. So you'll notice it says x plus 2. Right here, there's a coefficient just of 1. If you got a coefficient of 1, synthetic division is the way to go. So let's set it up. You remember that if we have a plus 2 right there for synthetic division, we're going to now have to put a minus 2 in the little box. Then we put all the coefficients of the polynomial outside it, right next to it. And we're going to have our little line here. We will be using addition. Don't forget, the first term drops straight down. So there's a 4. Then you're going to do the negative 2 times 4, giving you negative 8. Then negative 2 plus negative 8, giving you a negative 10. And then we're going to multiply the negative 2 by the negative 10, giving us a positive 20. And 5 plus 20 giving us 25. So what you should see here is this, all right, not 0. So because it's not 0, the answer is going to be no, all right? That binomial, x plus 2, does not perfectly go into the polynomial 4x squared minus 2x plus 5. So all of that to basically come up with the answer is no, it won't work. All right, let's move on to number 2 here. Factor, and specifically factor by grouping, because you'll see we have 4 terms. All right, so what I'm going to do is rewrite this, but it's going to be grouped, all right, in pairs. And so the x cubed minus 2x squared, I'm going to keep them together because they share something. And then I'm going to put the negative 9x plus 18. Just keep them together because they share something too. You don't want to group 2 terms together if they share nothing. All right, but each of these groups, they share something. So what I want you to see is that the x cubed minus 2x squared, they both share an x squared, meaning I can take x squared out of each of them. And the negative 9x plus 18, they share a negative 9. We can take a negative 9 out of each of those. So let's go ahead and rewrite this. We're going to factor out that x squared. And then what's left over is x minus 2. Okay? And then we're going to factor out the negative 9. And what we have left over, look at, got a bit of a magic trick here. X minus 2, x minus 2. If you do not get identical binomials after you factor out what they share, you've done something wrong. All right, it's a checkpoint. It's an easy way to determine if you are going down the right path using factor by grouping. Okay, so make sure that you know if you have factored out the correct term here and here, that inside those binomials must be identical. They are. So we can then keep moving on and proceed to the next part. These guys will now make their own binomial. X squared minus 9, and then the x minus 2 is still there. All right. When you have identical terms, x minus 2, one is dropping out, leaving another one left over. But what you need to notice is that this guy right here, this is a special binomial. This is a perfect square binomial. All right. X squared is a perfect square. 9 is a perfect square, and it must be subtraction. So all 3 parts check out. That means we can actually factor one more time here. X squared minus 9 actually becomes x plus 3, x minus 3, and the x minus 2 simply drops down into the answer. And this is our final solution right there. Okay, so you're breaking this 4-term polynomial actually all the way down into 3 individual binomials. All right, let's now look at example 3. Okay, so what you're given is 8 plus x to the power of 6. We're now going to use what's called the sum of 2 cubes. That is why this part right here really needs to be copied into your notes. If you haven't done that, pause it. Take the time to do that, because we're now going to reference that in example problem 3. Okay, so what we have is 8 plus x to the 6th. We need to find out if it's possible to make the number 8 convert into a cube. And is it possible to make x to the 6th power convert into a cube? The answer is yes. We can do it for both. All right. So here's how we do that. So 8 actually is the same thing as 2 to the 3rd power. That's what I mean by convert the number 8 to a cube. And then x to the power of 6 is the same thing as saying x squared then to the 3rd power. So now you'll notice both of these terms are cubes. So now we can proceed and use what's called the sum of 2 cubes. That's where that chart comes into play. All right, using that chart, we're now going to break this down into a binomial next to a polynomial. So you're looking at a plus b. All right, there's a, there's b. So this is now 2 plus x squared. Okay, and you'll notice we don't include the cube. All right, once you know that it is cubed, a is just 2, b is just x squared. Okay, so now the next thing we do is we have a and we square it. So 2 squared makes 4. Put a minus sign. Then they say take a and multiply it by b. And so now you're going to look at 2x squared. Then we have a plus sign. And then it says take b and square it. Well, if I have x squared and I square it, that's now actually going to make x to the 4th. So that's what we get right there. Okay, so that means that this is the solution to the original 8 plus x to the 6th. So we are factoring that down. Okay, now we're going to do the exact same thing for example problem number 4, but now it's a difference of 2 cubes, meaning we're subtracting 2 things that can be converted into cubes. But what you might notice is 2x to the 5th minus 16x squared. They share something. So before we even look to see if we can convert that into cubes, factor out what they share. That's very important and a key step to factoring any problem. If you can factor something out in the original, do that first, then proceed. So what we can factor out is a 2x squared. Then let's rewrite what we have left over. This now becomes x cubed minus 8. All right, now in the problem right up above it, we know that 8 can convert to just 2 cubed. Now, x to the power of 3, that's already given. That's already a cube. So that's quite nice. X to the power of 3. We're good with that. And then don't forget to keep the 2x squared in front, because that's not disappearing. It's just going to kind of hold a place right there. All right, now let's keep moving. So we got 2x squared. We're going to have the binomial, and then we're going to have the polynomial. All right, so use that chart. We do a minus b. All right, so what is a? A right here is just x, and b right here is just 2. So a minus b is simply x minus 2. Then it says do a squared. Well, again, a is just x. So we have x squared plus a times b. I know we're going to kind of flip the order. Instead of going x times 2, just say 2x. That's the common way of doing that. And then another plus sign. We do b squared. Well, if b is just 2, 2 squared is 4. So now what we have right here, that is our solution to the given 2x to the 5th minus 16x squared. All right, that covers all the example problems. That's everything you guys need to work through section 4 for factoring polynomials. All right, see you guys in the next one.